In this example, we're given the equation for the supply curve and the demand curve, and we're asked to calculate the equilibrium, Q star, P star, and then to analyze the impact of a $5 per unit sold tax imposed on this market. So let's start by graphing out the supply and demand curve. So the demand curve is given by this following equation. The demand price is equal to 20 minus 2 times the quantity demanded. And the supply curve is given by this equation. The supply price is equal to 3 times the quantity supplied. So let's start by graphing those. The demand curve has a y-intercept of 20. So we start there at 20, and then there's a negative slope, right? We know the demand curve is always downward sloping. The slope is -2. So there we go. There's our demand curve. For the supply curve, we have an intercept of 0, so that's where we start our curve. And we have a positive slope, right? The supply curve is always upward sloping. In this case, the slope is 3. So there's our supply curve. And we know that the equilibrium will be at the intersection of supply and demand, Q star, P star. All right, so the next step is to actually solve for Q star and P star. So we can, again, do this two different ways. One is to set the supply equation equal to the demand equation, because we know in equilibrium these two are equal, and only in equilibrium are they equal. So we know that the Q that sets these two equations equal is Q star. So solving for this, we would get Q star equals 4. And then plugging back into either the supply or the demand equation, we'll get the answer for P star. So I'll go with the supply equation because it's a little simpler. 3 times the quantity is $12, right? So we know that Q star is 4 and P star is $12. Right? The other way we could solve for this is by plugging in numbers. So for both equations, so we could plug in different values for quantity and see what the demand curve spits out and what the supply curve spits out. And when we find a match, that's when we found our equilibrium. So we could start at, let's say, 1, plug in a 1 for the demand curve up here. So 2 times 1 is 2, -2. 20 minus -2 is 18. For the supply curve, 3 times 1 is 3. So let's put that in. 18 for the demand price, 3 for the supply price. Okay, if we plug in a 2 into each equation, the demand curve spits out 16, and the supply curve spits out 6. If we plug in 3, the demand curve spits out 14, and the supply curve spits out 9. And if we plug in 4, the demand curve spits out 12, and the supply curve also spits out 12. So we have found our equilibrium, confirming the math we had done up here. Okay, so now that we have we've figured out the equilibrium, let's see what the imposition of a tax would do. So in order to impose a tax, we can do this two different ways. One is to think of this as the tax increasing our marginal cost of production. So we would shift in our supply curve by the amount of the tax, $5. The other way to do it is to think of the tax as reducing the marginal benefit of consumption for consumers by $5 per unit. So we could shift in the demand curve by that $5. So we choose one of those approaches, not both, right? So either we shift up the supply intercept by $5, or we shift down the demand intercept by $5. If we did both, we would actually be imposing a $10 tax, which is not what we're trying to do. All right, so I'm going to go ahead and impose this tax via the supply curve. The final outcome is going to be the same regardless. So the supply curve is going to start 5 units higher because our tax is $5. So this supply curve is just the original one, and we've added the tax, right? So our equation for the supply curve is now different. The supply price is equal to 5 plus 3 times the quantity supplied, right? And the demand curve is still as it was originally. So to find the new number of transactions with the tax, we look at the new intersection of supply and demand, which is right here. And this quantity, we'll call it QT for tax, will tell us how much lower or how much smaller this market is because of the tax, right? And once we figure out QT, we can then figure out the corresponding price here. This will be the price that consumers pay with the tax. It'll be something higher than what they were paying before. And then after the consumers pay their now higher price at the store, the seller's going to have to send in the $5 to the government. So when we subtract away the $5, we end up here with the price that the producers or the sellers are going to get to keep. So the gap between these two prices will be equal to the tax amount, which is $5. All right, so how do we figure out all these numbers? All right, well, let's start by figuring out QT, the quantity of transactions with the tax. Okay, so we can do this the same way we figured out our equilibrium before. We plug in different values for Q and see what the demand curve spits out and what the new supply curve spits out. So we can call this PS plus 5, right? And then we just see where we have a match. All right, so let's start at 1 again. So when we plug in 1 into the demand curve, we get 18. When we plug it into the new supply curve, we get 8. In fact, everything's just going to be 5 units higher than what it was up here. Right, so if we plug in 2, we get 16 and 11. When we plug in 3, we get 14 and 14. Aha, there is our match. So this is the new equilibrium with the tax. So the quantity is now 3, which is less than the original quantity of 4. And the price up here is going to be $14. So consumers are now going to pay $14 instead of $12. And then of that $14, the seller doesn't get to keep all that. They have to send 5 of it to the government in the form of tax revenue. So the seller gets to keep 14 minus 5, or $9. So before the seller got to keep $12, now they only keep $9. So we can actually talk a little bit more about the tax in terms of who is bearing the brunt of it. So the consumer's burden per unit bought is $14 minus $12. So they're paying $2 of every $5 paid in tax. The producers in this case before they were getting to keep $12, now they only get $9. So they are essentially paying $3 of the $5 tax, right? Together, when we add up the tax burden for the consumer and the producer, we get the total of $5 per unit sold, right? Later, we're going to talk about why it is, in this case, that the producer ends up paying a larger fraction than the consumer. In other scenarios, it'll be the opposite, where the consumer will pay more than the producer. Finally, we can calculate the overall tax revenue being collected by the government. So the tax revenue is just equal to the amount of the tax times the number of transactions. So in this case, $5 per unit sold, and there are 3 units sold. So the overall tax revenue is $15. In the graph, we see that as this big rectangle here, right? So this height of this rectangle, the wedge between the supply and demand curves, is equal to the $5 tax, right? And then this is equal to the number of transactions, 3 transactions. So this whole rectangle represents the tax revenue collected by the government.